Hi class, this is Mrs. Lyons. This video will be going over how to do names and formulas for ionic compounds that contain a transition metal. Okay, so as you know, we've kind of avoided the transition metals because we've said that they don't follow the rules. So we have to have another system, a little bit of a specialized system to write names and formulas because those transition elements can have more than one charge. Okay, so let's see what we know already. Transition metals are in groups 3 through 12 on your periodic table. All right, these elements can form ions with more than one charge. That's what makes them special. All right, tin and lead also do this. So tin and lead, if you look, tin and lead are not in groups 3 through 12. They go over to 13 and 14, but they behave as transition metals because they can have more than one charge. All right, to show the charge, you're going to write the charge using Roman numerals. Okay, and there's a table of Roman numerals here on this page, and there's also a table of Roman numerals on the back of your periodic table. Okay, the Roman numeral shows the charge on the metal. Okay, there are a couple of exceptions, things that you need to, things that you need to remember. There are 3 exceptions: zinc, silver, and cadmium. Okay, they can only have one charge. Okay, zinc forms a +2 ion, silver forms a +1 ion, and cadmium forms a +2 ion. So you'll need to remember those. Okay, the rest we will talk about how we're going to go about figuring out from their name what the formula is. Okay, so the steps to determining how to convert a name to a formula. All right, the first thing we have to do is we have to determine the charges of the ions. Okay, the metal's charge is the Roman numeral. All right, so what we're going to do is, just like in our other examples, we are going to crisscross the charges of the ions. Okay, and then we're going to rewrite the formula, all right, using the subscripts, all right, that are included at the bottom. Okay, and then if necessary, we have to simplify or reduce. Okay, so let's look at some examples. All right, so our first example here is copper, Roman numeral 1, chloride. Okay, so the symbol for copper is Cu. All right, the Roman numeral 1 tells me that the charge on copper is a +1. Chloride is in group 17, so the charge on chloride is, not -7, it's in group 17, it's going to be -1 is going to be the charge. Okay, so we don't have to crisscross those, they cancel out, so our formula is just going to be CuCl. All right, look at the second example. We again have copper and chloride. Okay, this time the charge on the copper is +2. That's what the Roman numeral tells us. And chloride is again -1. All right, so now the 2 becomes the subscript behind the chlorine. The 1 is behind the copper. Remember, we don't have to write ones. If you do, it will not count against you. Okay, so the formula is going to be CuCl2. All right, let's look at number 3. Iron 3 chloride. Okay, so we know that we have iron, and we know, again, we have chloride. In this case, the charge on the iron is 3. The chlorine is -1. All right, so the 3 comes down behind the chlorine, the 1 down behind the iron. So our formula ends up being FeCl3. All right, one more. Okay, iron 2 oxide. All right, so we've got iron and we've got oxygen. Okay, so iron is +2. Oxide is -2. So right away we should know that those two charges cancel out, leaving us with FeO. Okay, now if you're watching this video at home because you missed class or you're going back to make up some stuff that you missed, turn the video off and try these 4 in the practice column. Okay, so turn the video off, practice, and then come back when you're done, and we will look at we'll look at what the formulas are. All right, did you try it out? So let's look at what we've got. So we've got gold 3 oxide. So the 3 tells us the charge on the gold is +3. Oxide is oxygen, -2. So if we crisscross these, we get AU2O3. All right. Number 6, cobalt 4 nitride. Okay, so the cobalt, the charge is +4. Nitrogen is -3. So if we crisscross, we get CO3N4. Lead 4 sulfide. All right, so in this case, the lead is +4. Sulfide is -2. If I crisscross those, I get Pb2S4. Okay, so notice what's going on here. We can simplify. If we divide both of those numbers by 2, we get PbS2 as our correct formula. All right, number 8, manganese 2 selenide. All right, so manganese has a +2 charge. Selenide is selenium, it's in group 16, so it has a -2 charge. Again, those are going to cancel out. Our formula is just going to be MnSe. Okay, how'd you do? Hopefully you're getting more comfortable with this. All right, now the trickier part of this, let me get my notes in the right place, is if we're given the formula, okay, we have to figure out the name. Okay, so right now we've been doing name to formula. Now we need to do formula to name. All right, so in doing that, what we can do is we can reverse crisscross. All right, we reverse crisscross the charges. Okay, now when we do this, we've got to double check the nonmetal's charge, okay, to make sure that it hasn't, there we go. Sorry, I got blurry for a minute. We've got to double check the nonmetal's charge to make sure that it hasn't been simplified. Okay. So what we're going to do is we're going to record the name of the transition metal with the charge written as a Roman numeral in parentheses. All right. We're always going to change the ending of the nonmetal's name to include IDE. Okay. So let's look at how this works. All right. So we have Ni2O3. I'm going to write this over here. Ni2O3. Okay, now, if we reverse crisscross, what that means is we're going to bring the 2 up here, it's minus 2. The 3 up here is plus 3. Okay, now, what we mean by checking the charge of the negative, the nonmetal, the anion, we've got to make sure. So this tells us the charge on oxide is minus 2. That, in fact, is true, which means this formula is correct. So we have nickel plus 3, so 1, 2, 3 oxide. All right, let's look at manganese sulfide. All right, so if we crisscross, we've got MnS2. So we assume a 1 here. Okay, so if we reverse crisscross, this becomes a plus 1, this becomes, or excuse me, a minus 1, and this becomes a plus 2. Now, if you look on your periodic table, the charge on sulfur is not negative 1, it's negative 2. So this is one of those compounds that has been simplified. Okay, so if the charge on sulfur should be minus 2, I'm going to multiply my charges times 2, which means the manganese would be plus 4, sulfide minus 2. So we would have manganese 4 sulfide. All right, if you're watching at home, pause the video and try these for practice, and then come back and check your answers. All right, so how did you do? Let's check it out. So SnCl2, I'm going to reverse crisscross that. The 2 comes up here as a plus 2 and minus 1. Chlorine is a minus 1 anion, so this is going to be tin 2 chloride. All right, let's look at the second one. SnCl4. If I reverse crisscross, the charge on tin is plus 4, the charge on chlorine is minus 1. Okay, and chlorine is a minus 1 anion, so this is going to be tin 4 chloride. All right, FeO. So if there are no subscripts, we assume that they're 1. If we reverse crisscross, iron would be plus 1, oxygen would be minus 1. If you look at your periodic table, oxygen is not a minus 1 anion, it's a minus 2 anion, so I need to multiply both of my charges by 2. So I end up with iron with a plus 2 charge oxide. All right, one more. Nickel bromide. So we've got NiBr3. If we reverse crisscross, we find that nickel's plus 3 if bromine is minus 1, and it is. So this is going to be nickel 3 bromide. Okay. Let's see. All right.